Okay. We are doing the question number third question of exercise 6C. Okay. Find the equation of the plane that is perpendicular to the plane. एक प्लेन उन्होंने दिया हुआ है, एक प्लेन उन्होंने दिया हुआ है 2x minus 4y plus z is equal to 10, and then they have given us another plane x minus 4z is equal to 2, and the plane that we want to, the equation of plane we want to calculate contains the point 2, 3, 1. Okay. Now I try to draw the diagram. This is one plane. So these are the two planes which are intersecting, and the plane that we want to calculate, equation of plane that we want to calculate is perpendicular to both of them. Okay, it's like this. Or I think the best way to draw it is like this. Consider this is a plane. Consider this thin line as a plane. You know, if you look at the paper from one side, if you look at the sheet of a paper from one side, you know, it appears as a thin line. Now consider this line as our plane 1, okay? And you are looking it from the side, so it appears to you as one line, okay? Now the second plane is also like a thin line, okay? So that means you have shown two planes in such a way that you're looking them from side, okay? Now you have to calculate the equation of this white screen. Consider the white screen. This white screen of the tab is the third plane whose equation you want to calculate. And clearly, this third plane is perpendicular to the plane number 1, phi 1, and plane number 2. And this plane also contains a point 2, 3, 1. So that means we have to find the equation of phi 3, which is the screen of the tab. You know, screen of the tab is also a plane. And this plane is perpendicular to this, the two planes that I've shown by thin lines, okay? These lines are, these are not lines, these are planes when looked from the side. For example, you know, if you look on a sheet of paper from one side and the sheet of paper is perfectly plain, and there is, and you're looking from perfectly one side, one thin edge, it will appear as a thin line. I hope you understand the image that I wanted to create in front in your in mind. Have you understood it or not? G.
Ji, sir.
Okay. Now the question, though, the point is that, you know, you have been told that if you want to know the equation of a plane, you need a vector normal to the plane. So how will you calculate a vector perpendicular? How will you calculate a vector perpendicular to the screen? How will you calculate a vector perpendicular to this screen? You know, this is N2, and you can find the N2. N2 is a vector normal to this plane, and you can write it like this. And as you know that N2 is equal to 1, 0, and minus 4. You know that the coefficients of x, y, z are actually the components of the vector normal to the plane. You know it for sure because it has been told to you, and you must have noticed it yourself. Now, this is another plane. This is another vector normal for n1. Now, n1 is a vector normal of the plane 1. And if we use these numbers, we can find n1. n1 is equal to 2 minus 4, 1. This one comes from this point, okay? Now, I'm sorry. Okay. I hope you understand that how we have obtained these vector normals of plane phi 1 and plane phi 2. And you know, a vector normal to this screen, a vector normal to this screen will be what? Can you tell me how
The
can
cross
we find?
product of n2 and n1.
Yes. Okay. So our vector normal of our required plane is cross product of n1 and n2. Okay. Let's calculate the cross product of n1 and n2. We write n1 and n2 adjacent to each other. And then by using the technique that we know, it's 16 minus 0 minus 8 minus 1 and plus 4. When we simplify it, 16, 9, 4. Okay. So this is the vector normal. This is what? This is the vector normal of the plane that we want. And we also know a point on the plane. So it's very easy for us to calculate the dot product of a general point with this vector normal, and then the dot product of point on the plane with this vector normal. And now this is the equation of the plane that we were talking about. 32 plus 27 plus 4. So it's 16x plus 9y plus 4z is equal to 63. But I hope you understand. G. Hello. I hope you
Assalamu alaikum,
understand
sir.
it. Wa Islam. I hope, Beta, is there any question regarding this question?
No, sir. No, sir.
Okay. Okay. Now, let's turn our attention to the question number 5. Let's turn our attention to the question number 5. Let's do this question number 5. It says, find the shortest distance between a point. The point is 5, 2, 6. And the plane that passes through the point 2, minus 3, 2. And the vector normal to the plane is I plus j. Find the shortest distance between the point 5 to 6 and the plane that passes through the point 2, minus 3, 2. The plane passes through 2, minus 3, 2. Okay. Here, how can we do this thing? How can we do this thing? How can we find the distance of a point from a plane? First of all, I would like to find the equation of the plane. So our first job is to find the equation of the plane. finding equation of the plane. Finding equation of the plane. Okay. We know that R dot n is equal to A dot n. And R dot n is, I plus j. And A is 2i minus 3j plus 2k dot n I plus j. This time I'm using a different kind of notation. It's not different from the one that we've been using previously. Previously, I was using this notation. I was doing it like this. I just want to tell you that these two are similar to each other, and you should not get confused by use of any of the either. Okay. Now, if we simplify, if we try to convert it into Cartesian form, we can write R as xi plus yj plus zk dot I plus j is equal to 2 into 1 minus 3 into 1 over here, and it is x plus y is equal to minus 1. This is the equation of the plane. Or if we want to write it in a standard style, we should write it like this. This is the equation of the plane, okay? And our job is to find the distance. Which distance we want to find this red length? We want to find this red length. This is the distance of point from the plane, okay? In order to calculate this distance, we will first of all we will imagine this blue line. This blue line, which is passing through the plane. It cuts the plane at 90 degree. And this line L, we want to calculate the equation of this line L. And the equation of this line L can be easily calculated. We just need to know a point on the line, which is this 5 to 6. And we should have a vector parallel to the line, which should act as a direction vector of the line. In order to know the equation of line, you need a point on the line. Then you need to know a vector parallel to the line. Can you tell me if there is any information available in this diagram which can help you?
Normal vector of the plane.
Yes, you're right. The vector normal of the plane will act as a direction vector of the line, okay? The vector normal to the plane will act as a direction vector of the line. We will call it as D. The same N of the plane is the D of the line, okay? Although that I previously used symbol D for this distance, I would call it D1 rather, because simple D I am using to illustrate that equation to illustrate the direction vector. Okay, now the equation of line is given like this. Where A1 is any point on the line. And you know that 5 to 6 lies on that line. And the direction vector is 1, 1, 0. So this is the equation of the line, which can be written like this. Which can be written like this. And let me rewrite it again so that it should appear very clearly. And you know that this is also coordinate of any point on the line. Okay, this is the general coordinate of any point on the line. We call this 5 to 6 as our P as P. Okay, we call 5 to 6 as P. And this vector, this point where the point of intersection of the line and the plane, we call it Q. Now we have to find the coordinates of Q. in order to find the coordinates of Q, we will solve the equation of the plane and the line simultaneously. We will solve the equation of the plane and the line simultaneously, and we will insert these values in this plane. Lambda is equal to -4, okay? Now you insert this value in this equation of plane. The coordinates of Q will come equal to what? The coordinates of Q will become 1, -2, and 6. I have obtained these values by inserting this -4 over here, and then simplifying, okay? 5 minus 4 is 1, and 2 minus 4 is equal to -2. Now it's very easy for me to calculate this distance PQ by applying the distance formula. I know that the distance formula PQ, I know in order to calculate the distance for a distance between the 2 points, I will use this formula. X1 minus X2 minus X1 whole square, Y2 minus Y1 whole square, Z2 minus Z1 whole square under root. Okay. So this is the distance formula. This is the distance. I can use this formula to calculate the distance between PQ. And hence PQ is equal to 5 minus 2 whole square, 2 minus -3 whole square, plus 6 minus 2 whole square under root. And this is equal to 3 square plus 5 square plus 4 square under root. This is equal to under root 50. Have you understood this? Any question? जी बेटा. Any
सर
question?
एक सेकंड सर, ये गलत हुआ है
Where I have made a
सर.
mistake?
अच्छा सर, आपने जो लैम्डा निकाल लिया, ठीक है, तो आप लैम्डा को ये डायरेक्शन वेक्टर 110 के साथ मल्टीप्लाई कर दें और फिर उसका मैग्नीट्यूड निकाल दें, क्योंकि सर उसका आंसर 4√2 आएगा, जो पीछे भी सही है.
नहीं, मुझे एक बात बताएं. 4√2. एक मिनट. Just let me see. I have, if I have used a right method, okay. If the answer at the back is not matching with my answer, then I've made some numerical mistake. I haven't done any methodologic. I haven't made any mistake method by method wise. Okay,
जी सर, मुझे पता है सर.
methodically speaking, I have done it right. Please check if I have done something wrong. There should be some evidence.
Q के coordinates गलत use कर रहे हैं.
Say how come?
Q के 1 minus 2 6.
Huh?
Q के sir 1 minus 2 और 6.
So the Q के coordinates ये क्या गलत निकले हुए? Are they wrong?
सर आपने डिस्टेंस
सर,
फार्मूला
आपने
में
2
गलत वाले
minus
डाले
2
हैं.
और 2 use किए.
अच्छा, okay. 5. Oh. Yeah, I mixed. Okay. The coordinates of Q are over here are 1 minus 2 6. Okay. So I confuse the. I call this point as say A. Okay. I mixed those coordinates of A with the coordinates of Q. Okay.
सर वैसे आप इस केस में लंबा चक्कर काट रहे हैं. आप आसानी से लैम्डा और 110 वाले वेक्टर को मल्टीप्लाई करके उसका मैग्नीट्यूड निकाल लें.
Say it again. दोबारा बोलें.
सर आप डायरेक्शन वेक्टर जो 110 है उसको लैम्डा के साथ मल्टीप्लाई कर लें और उसका मैग्नीट्यूड निकाल दें तो आंसर वही आ जाएगा जो आप अभी निकाल रहे हैं।
आप ठीक कह रहे हैं, मुझे उसमें ये ना कि लेट मतलब मुझे इनको बताना भी तो है ना, आई हैव टू एक्सप्लेन इट, यू नो। अभी मैं बताता हूँ वो, ठहरो। आप कह रहे हैं कि you just mentioning that just take the magnitude of this. This is what you want to say?
Yes, sir.
Okay. Just a minute. मैं भी इस तरफ आता हूँ. But I have to first tell them that why is it so? 5 minus 1, 5 minus 1 whole square plus 2 minus 2 whole square plus 6 minus 6 whole square, and this is equal to 4 square plus 4 square. It's 32 under root, and it's 16 into 2 under root, and it's 4 under root 2. So this is the right answer. Okay. Now I try explaining the method that I'm going to explain the concept that Safi is pointing out. Let us suppose this is a plane, okay? Okay, this is a plane, okay? And this point PQR is the point whose distance from the plane we want to calculate. It is this distance that we are interested in calculating, okay? Let us call this point as capital P and call this point as Q. And then this is the equation of line. And this is the vector normal. The vector normal is, A, B, C. The vector normal of the plane is going to act as a direction vector of the line, okay? So the equation of line is R is equal to PQR plus lambda times ABC. This is the equation of the line, okay? This is the equation of the line. In order to calculate the coordinates of Q, you know that the coordinates of Q will be, say, let's call them x1, y1, z1. And if we apply the distance, this point is equal to P plus lambda A, it's Q plus lambda B, and it's R plus lambda C, okay? Over here, this is the equation of the line, okay? Now, according to what Safi is saying, is that when you apply the distance formula on PQ, when you apply distance formula on PQ, and P minus x1 whole square, Q minus y1 whole square, and R minus z1 whole square, he says that upon simplification, this turns into lambda A square, lambda B square, and lambda C square. And a person should directly calculate the distance formula by using this relationship or inserting the value of lambda only in this region, in this portion, and just calculating its magnitude. Is this, Safi, you're saying? Is this the point that you're raising?
Yes, sir.
Acha, theek hai. Beta, but don't you think that the rest of the people will be unable to digest this? They will definitely ask that how P minus x1 becomes equal to lambda A, and how Q minus y1 becomes equal to lambda B, and how R minus z1 will become equal to lambda C. We will have to establish a proper proof for them to really digest this idea. So should we prove it? जी शुरू करें भाई. Do you want to dive
Yes, sir,
into
शुरू
some
कर दें.
complex things? जी बाकी लोगों का क्या राय है?
सर और क्वेश्चंस कर लेते हैं.
हाँ
और क्वेश्चंस कर लेते हैं.
और क्वेश्चंस कर लेते हैं. You're not interested
ये
in
वाला मेथड भी इजी है
कौन से वाला?
सर, ये जो सफी कह रहे हैं.
नहीं, the method is indeed very easy. It's a shortcut, but you know, you should know why. My
प्रूफ करवाएं.
Hmm?
प्रूफ करवाएं आप.
I haven't proved it. No? You know, how can this blue thing becomes this blue thing, and how come this purple thing becomes this purple thing, and how come this green thing becomes this green thing? This is what the point is. Okay. No, let's do it. Okay. Let's, and this will also actually before Safi mentioned it. Today I was thinking of telling you a shortcut. Okay. Before I prove this expression that Safi said, let me explain what was in my mind. Okay. This is a plane, and ax plus by plus cz minus d is equal to 0 is its equation. I've brought everything on the left hand side, right? And the point that we want to calculate, the distance of a point we want to calculate from the plane is this point, PQRS, represented by capital P, okay? But before I quote any formula, I want you to refresh your knowledge of your coordinate geometry. This, look at the left hand side, ax plus by plus c is equal to 0. This thing represents a line, okay? This is the equation of this line, and this is the point, and we want to calculate the shortest distance between the line and the point. We want to calculate this shortest distance. We want to calculate this shortest distance. And formula, direct formula for this short distance is a b c under root a square plus b square, and then inserting p over here, inserting q over here, and then taking the modulus sign to remove any negative sign appearing. This is the formula for the shortest distance between the line and the plane. I just want to know how many of you know this formula. How many of you know this formula? G. How many of you know this formula? G. Beta, how many of you know this formula? For example, if
Sir,
this
I have
is
seen this formula before.
you are a great boy. Okay, if this is a point, and if I want to calculate the distance of 1 from this line, I want to calculate the distance of 1 from this line, and I'm interested in knowing this red distance. I will do what? 3 into 1. I will insert the coordinates of point in the equation of line, and then I will divide it by the sum of the square of the under root sum of the squares of the coefficient of x and y. This will directly give me the distance of point from the line. Okay, this is 12 over 5. This is 2.4. So 2.4 is the distance of point from the line. G. This is the formula which normally teachers teach in P1 when they are doing coordinate geometry. Okay, this is a very useful formula. Now, thinking on the same line, we can write the equation, we can find the distance formula we can write a distance formula of which should give us the distance of a point from the plane. And the formula is this. The formula is this. And this is shortest distance of point from plane. Okay. Modulus is there to remove any kind of negative sign. Now, if you memorize this formula, you can code this formula directly. Okay. And in this particular case, instead of doing all working, you could have simply used this formula directly. Okay. I think I should redraw this whole question again rather than erasing the previous. You know, this is the plane. Its vector normal is I plus j, and it contains a point. The point was equal to what? The point was equal to 2, comma minus 3, comma 2. Okay. And then this point was on the plane, and the point from where we wanted to calculate the distance from the plane is 5, 2, 6. Okay. We were able to, we calculated the equation of plane, which was equal to what? X plus y is equal to -1. I think x plus y, yes, it's -1. So the equation of the plane was x plus y is equal to -1. Okay. Now, if we want to apply directly this formula, we can write the equation of plane like this, and then we just directly insert these points. 5 plus 2 plus 0 into 6 plus 1 under root. And then, you know, the coefficient of x is 1, 1 square. The coefficient of y is 1, 1 square. And the coefficient of z is 0 square. And this gives me the shortest forward distance of the point from the plane PQ. And this becomes equal to 8 under root 2. And when you rationalize it, when you multiply and divide by under root 2, you get 4 under root. This was the shortcut, okay? And my intention was to use this formula, okay? And the proof of this formula can be established. It might seem lengthy, but it's very easy. And I would request you, instead of, I want you to prove it. You should try your uh, uh, luck in order to establish this. And then you should also derive this thing that how Safi was right in saying that the distance PQ will become equal to this. In fact, if you try proving this, you will automatically come to this proof in the middle, okay? When we are trying to find the proof of this formula, in the middle, you come across this PQ distance, and then you are able to arrive at this thing. So that means if you try to find the proof of any one of them, you will establish both of them. You will establish both of them. I hope you understand it. Hello? I hope you will try to do it. If you want me to do it, Andal, you want me to do it, I can do, but you know, this will make it much
नहीं सर
boring.
नहीं सर we'll try it.
Okay, you try to. In the meantime, I do some other questions. Okay.
Okay.
Okay. Yes. How will you find the acute angle between the two planes? Question number 6. How will
Sir,
you
the
find?
angle between their normal vectors.
Okay, no, consider this is one plane, okay? We call it phi 1, okay? And then consider it, this is the second plane, phi 2. And we are looking at them from their edges, okay? The equation of phi 1 is 2x minus y plus 4z is equal to 13. And the equation of phi 2 is 3y minus 2z is equal to 4. And this is the angle theta between the two planes, okay? Now their vector normals can be like this. For example, the vector normal of this f for phi 1, we can show it like this, n1, and the vector normal of the phi 2, we can show it like this. Okay. Now this is the angle theta. This is a special case. Not always the geometry of the normal vectors will be like this, but if we assume that this is the case, we can find the angle theta directly by using dot product. You know, cos theta is equal to n1 dot n2 divided by n1's magnitude and n2's magnitude. Okay. Now cos theta is equal to, you know that n1 is equal to 2 minus 1, 4, and n2 is equal to 0, 3 minus 2. Okay. Now 2 into 0 minus 1 into 3 plus 4 into minus 2. And then we take their magnitudes, 4 plus 1 plus 16, and then 9 plus 4. Okay. So cos theta is equal to minus 3 with minus 3 minus 8 and then under root 21 and under root 13. And cos theta is equal to minus 11 over under root 21 under root 13. You know, this, can somebody calculate this angle for me, please? Tell me the angle. G. Can somebody calculate this angle? Can somebody calculate this angle for me?
Sir,
G.
131.7.
1.
Sir, 131.7 या 48.3 इनमें से
Okay, acha. Just this is not this angle does not represent the situation that I have drawn. In fact, this angle tells me that these are the two planes, okay, and their vector normals are like this. Their vector normals are like this. Their vector normals were not pointing in the direction that I showed. And it is due to this reason that the angle that we have calculated is obtuse, is greater than 90. Okay, when the angle is greater than 90, the vectors point like this. And since this is 131.7, and the acute angle, and this represents this angle, 131.7, okay? And the acute angle between the two planes is equal to 180 minus 131.7. So this thing equals to what? G. Please tell me the answer.
Sir,
Hello.
48.3.
40.3.
48.3.
So this is how we calculate it. Okay.